Welcome to the 2018 Telemanagement Forum Catalyst demo. My name is Pedro Benito. I am Atos Codex for Telco and NFV Solution Manager, and I was responsible for the design and the delivery of this 2018 TMF Catalyst project. In this video, we will show you the key aspects of the TMF 2018 innovation project called Customer Experience Management and Service Assurance across hybrid networks, predictive analytics, and dynamic offers creation. This project was presented during the Telemanagement Forum Digital Transformation World event held in Nice during May 2018. The parties involved in this project were Ooredoo as CSP champion, Atos as systems integrator, Sigma as product catalog vendor, Sienna as network orchestrator vendor, and Dell as NFV infrastructure vendor. But we also used product from F5 such as Big IP PAN as a BNF, and Red Hat OpenStack 10 as the virtual infrastructure manager, as well as Huawei SmartCare probes and VMware. Okay, thanks. For this TMF 2018 Catalyst project, we implemented 3 different use cases. The common vision across the 3 use cases was to show how the Atos Codex analytics solution can improve the current way of working in different areas such as customer experience management, customer value management, service assurance, but also across different physical and virtual network functions in a hybrid scenario. Use case 1 was about dynamic mobile to FTTH cross-selling offers. Use case 2 was about video customer experience management for VNF service assurance. And use case 3 was about NFV infrastructure service assurance using machine learning. We will explain each of these use cases in more detail later on in this video. From the runtime perspective, Blue Planet's multi-domain service orchestrator, in conjunction with the Atos Codex analytics platform, provides today most of the key ONAP functionality. Different TMF APIs have also been leveraged for this catalyst, including TMF641 for service order orchestration, which is the interface between the Sigma order management orchestrator and the Blue Planet network orchestrator. From the end-to-end deployment perspective, the solution components included in this TMF 2018 Catalyst project have been deployed across 3 different labs. On the right side, we can see the Atos NFV lab sitting in Grenoble, including a Dell infrastructure, hardware, compute, storage, and networking. Red Hat OpenStack Virtual Infrastructure Manager, VMware providing VMware Virtual Infrastructure Manager. Sienna providing Blue Planet and DSO deployed on VMware. And F5 providing load balancer, policy enforcement manager, VNF deployed on Red Hat OpenStack. Secondly, the Atos Codex lab running in Zurich, which is including the Atos Codex for Telco solution components, which are based on different open source platform products, and they are implementing the different use cases. Third, the Sigma Systems Lab running in the Microsoft Cloud, which is providing dynamic offers, dynamic catalog, and the end-to-end order management product, which is deployed in the Sigma Lab running in the public cloud. So let's start with first use case. So for use case 1, the business problem we're trying to solve is the following one. There's a common situation in communication service providers where, they have home routers with 4G SIM cards as a run in areas where fixed access coverage is in progress. The associated problems in this situation are 3. Problem number 1, the customer does not know when the fixed access offer applies to him, since applicability depends mainly on current tariff, data usage pattern, and home location, of course. Problem number 2 is that customer experience is bad due to cell congestion caused by the heavy home mobile data users which are using intensively the services just such as video streaming. And problem number 3 is that the CSP suffers from mobile network congestion when actually if there's a fixed access available in the same area. So there's no possibility of doing data offloading into the network at that moment. The proposed solution we have developed is the closed loop analytics to optimize highly personalized dynamic offers creation and the related service activation in the context of heavy mobile data home users, which actually has FTTH coverage. The solution benefit, of course, is to have a better service and user experience for the customer, while reducing mobile cell congestion caused by heavy data traffic offload to FTTH. And of course, as well, we have a fixed access revenue increase acceleration for the CSP. The way we did that is through categorization of the data usage pattern across the different days based on Huawei's marker probes, and detecting different categories and enriching the cell ID with location of the subscriber in the mobile network, and automating the migration rules depending on the tariff, the category, and the coverage. As a result of that, we came up with an architecture where we have different interfaces. Functional architecture, basically on the left side, we can see Huawei's smart care probes acting as real-time data sources for the Atos products for telco analytics platform, also called AC4T. And that's interface number 1. Interface number 2, it's AC4T monitoring the customer experience management and detecting when a specific customer qualifies for the mobile to FTTH migration campaign based on mobile data usage pattern, and tariff, and location, as we mentioned before. Interface 3 is FTTH service order being sent to Blue Planet MDSO. Interface 4 is the F5 subscriber activation being sent to the F5 VNF. Meanwhile, Orido can monitor the closed loop events and metrics in real time with the Atos Codex for telco dashboards. If we take a look into the use case 1 dashboards, we can see in the first part of the dashboard, you can see the MSISDN numbers of the mobile data home subscribers. So these are fixed MSISDNs of the VoIP phone number of the home subscriber. The biggest one is the heaviest one, as you can see here. This is the total volume per month of that specific subscriber. As you can see, 1, 2, 3, 4, 5, 6 heavy subscribers in the area that we're monitoring, using more than 100 gig a month, which is quite significant. We can enrich the location of those subscribers, so we see where those subscribers are. The big circles are representing more than one subscriber or different subscribers in that cell. The different areas in green here are the FTTH coverage areas. So we can see that these 2 subscribers are in FTTH fiber coverage, but these are not. So this provides also visibility of where this expansion of the fiber network for covering heavy mobile data usage should be, as well as where some cells are congested with more than one heavy subscribers supported by the same cell. In this graph, significant number of heavy mobile data subscribers per FTTH area. In this graph, you can see different IDs and phone numbers, so you can see what is the actual data that is being used per cell. So in some cases, the same subscribers is using the traffic through different cells due to the radio coverage mechanism. So in this case, we use the cell that is using most of the bandwidth for that particular MSISDM. So we can also see some DPI insights of what applications are being used by each real mobile or radio Oman subscriber in this case. So we can see that this specific subscriber has been using a lot of YouTube streaming, as well as this one is being using a lot of file Windows access, for example.
Okay, so I'd like to start by giving you a little background of the models that we have in Catalog that are used to interpret the analytics event that is being sent to us. What you see here is the product manager view of the product catalog. And in here, we have defined a number of models to represent the products that are offered for home broadband and fiber to the home. For home broadband, you can see that there are a range of products that are here, and these are the existing products that customers have. The fiber to the home products are the newer products that are being used as the target for the upgrades. And you can see how there are different bandwidths made available for the various products. So we have 20 megabits per second, 100 megabits per second, right up to 1 gigabits per second. If we look in detail at those products, you can see that we have a structure in place that describes the commercial aspects of the product. So we have a breakdown of components that demonstrate how the home broadband product is represented in the system. We have a product specification, customer-facing service specification, and we have certain prices associated with the product, like a monthly fee and the cost of that fee, and as well as a representation of some resources like the modem and the charges that are associated with the modem. The other thing that we have in here, which is relevant to this particular example, is that there are a set of rules defined in the design of the concept, and I'll just bring this up here, that show how the various categories of event that we get from the analytics will be used to determine how an upgrade event is dealt with for a particular customer. So what you can see here is that there is a list of the target offers that we saw in the product catalog. So these are the home broadband offers. You can see that for each of the different bandwidths that are defined for the home broadband products, depending on the category that comes in and whether fiber is available in that particular region or not, the category of the analytics event determines the new target product that is offered to the customer. So if we go back to the product catalog, I can show in here that for the home broadband 500 product, we have a list of rules which are interpreted by the auto CSR application, so that when the analytics event comes in and it identifies that there's a fiber available and it's a category 1 event, we see that the upgrade offer that's presented is 1 gigabits per second. So once that analytics event comes in, an order is actually generated in the system automatically and we'll go and have a look at one of the orders that we've received for this user 7. And this is the list of orders in the order management interface. I'm going to drill into one of the orders, and here we can see that the actions that have been taken are to delete the home broadband 500 gigabyte product and to add the superfast fiber to the home product for 1 gigabit per second. So just like the rules were indicating in the catalog, this is the automatic event that's generated. And if we were to go and drill down further into the sequence of activities that are generated for this particular order, I'll be able to see that I have a sequence of top-level folders. If I drill down into one of these folders, I can see in the service activation activity, there's a create fiber to the home service, and this is where we generate an event going down to Sienna's Blue Planet to actually create the new fiber to the home service. And in here, what I can see is a telemanagement forum OpenAPI compliant activation request, which has come in. It identifies the user, it identifies the bandwidths that are required, so 512K, and it defines an appropriate IP address for the action that was requested for this particular customer. And we can see that we get a response back from Blue Planet with the fact that the event was processed successfully.
Now, to finalize use case 1, we can see here the dashboard of the Big IP VNF for specific user 7, which has been activated through a Blue Planet multi-base service orchestrator. So this is the monitoring dashboard of the Blue Planet multi-domain service orchestrator. If we go into the TMF's service resource type, we can see a specific user 7 resource and their model created for the TMF 2018 service, which contains different resource types for monitoring the bandwidth of the overload and the idle situation, as well as for monitoring or for provisioning the new subscriber policy. So for use case 2, the business problem we're trying to solve here is about video streaming service assurance. We all know that video streaming is one of the services causing CSP's network issues and bad user experience. So relevant data about video streaming user experience is sometimes available but not used, or is really hard to leverage by CSPs with their current service assurance on OSS tools. So what we have developed is a closed-loop real-time analytics solution based on Atos Codex to optimize the video streaming user experience over virtual F5 Big IP load balancers. The solution benefits is better video service user experience for CSP customers, reduce CSP service assurance costs, etc. So the solution is based on the integration of number 5 here is interface number 5. We monitor the F5 VNF deep packet inspection of the video streaming service. We generate some low bandwidth triggers, which is a customer experience management trigger, through Blue Planet, a multi-domain service orchestrator. And Blue Planet is changing the bandwidth policy when that happens changing the policy in the VNF through a REST API. So Atos Codex keeps monitoring that through the dashboard. The dashboard really looks like the following. Here's the bandwidth monitoring for each of the users. So these are different dates where different bandwidth has been used by different customers. So these are the different policy enforced in each moment. So whenever there's a high policy, you have a high bandwidth and it's detected. So when it's a good quality or low quality, the bandwidth of the assigned for each subscriber is changed automatically. As you can see here, the data consumption per service is also reflecting the fact that we have different application categories. So audio and video are most of the time the most consuming services in terms of bandwidth. And we can see different graphs about the DPI analysis per subscriber. So we can see that some of these users are using video streaming on Dailymotion or YouTube, for example. So for the third use case, the business problem we're trying to solve is the following. Operators deploying NFV are facing challenges to properly monitor all the additional NFVI layers introduced in their daily operations. OpenStack services generate a lot of data that is hard to leverage by operators with their current service assurance OSS tools. So the proposed solution that we having as part of this catalyst, as in use case 3, is to show a visual time series predictive analytics approach to automate NFVI anomaly detections. Of course, the solution benefit would be for operators to have a better operational efficiency across different virtual and physical infrastructure layers. What that means in terms of implementation is, you can see in the diagram, is that interface number 8 is basically retrieving metrics from Ceilometer through a Gnocchi time series database from OpenStack into Kafka Elastic stream processing. So we have some dashboards to show that, and how that is looking is in the following way. So we have here an example of a time series database for F5 CPU usage. You can see the algorithm is learning initially, and after a few cycles, it's already getting up to speed with the pattern detection. And you can see some anomalies detected at this point. So if you can zoom in into that period of time, what is really going on is assigning a high anomaly score for some of the KPI values which are not normal. So that is simplifying the way operators can monitor different time series database. And this is just the one dimension, the single metric. And the future evolution of we can have multiple dimensions for different KPIs at the same time in the correlation in the time manner. So that's basically use case 3 and how machine learning is applied for operational analytics.